Any curious kids who have caught a butterfly by hand, only to find their fingers coated in messy powder, have unknowingly brushed off the fluttering insect's scales. These microscopic plates cover almost every part of a butterfly, and are what help paint their wings a variety of colors, from shimmering cobalt blues to patterns of orange and black. While most people go to a garden if they want to see a butterfly's scales in action, Timo van Eldijk's search for wing scales required drilling more than 1,000 feet into the ground. Then, he extracted fossilized insect bits from black sludge using a probe tipped with human nose hair. In a study published Wednesday in the journal Science Advances, Mr. van Eldijk and his colleagues uncovered approximately 200-million-year-old wing scales belonging to ancient members of the insect order Lepidoptera, named for the Greek words for scale and winged, which include butterflies and moths. These scales are the oldest evidence of moths and butterflies, said Mr. van Eldijk, who was an undergraduate at Utrecht University in the Netherlands during the research. It extends the range to which we know butterflies existed by about 10 million years. The scales may also provide insight into the early evolution of the insect's tube-like tongue, or proboscis, which the authors suggest evolved tens of millions of years before nectar-rich flowers existed. Mr. Van Eldijk made the discovery while working with Bas van de Schoot-Brugge, a geoscientist at Utrecht University, on a project to investigate ancient pollen in the fossil record, particularly during the mass extinction about 200 million years ago that ended the Triassic period and ushered in the Jurassic. For that project, the team drilled deep below northern Germany in what was once an ancient lagoon to collect sediment from the time of the extinction event. They then dissolved the rock in chemicals that eat away any material that was not organic, leaving pollen samples behind in a black goop which the team could search through, drop by drop. But in analyzing the murky solution they stumbled upon a new mystery: several unknown scales were left behind in the gunk. The team soon discovered that the scales belonged to long-extinct relatives of modern butterflies and moths. Mr. van Eldijk was tasked with fishing out more, and for that job he was given a dissection probe with a single nostril hair. The nose hair has just the right length and springiness for getting a pollen grain, or in this case the butterfly scale, to adhere to it, Mr. van Eldijk said. I was just provided these by my professor. I don't know whose nose hair it was. It's probably best not to ask. He and his team uncovered about 70 scales or scale fragments, which they dated to about 200 million years ago. Using an electron microscope, they also found that about 20 of the scales were hollow. The hollow scales provided clues for another mystery, this one concerning the insect's mouths. Until this point, many of the most ancient moths and butterflies found were thought to have had mandibles, which they used to chew, rather than a proboscis, which is the straw-like mouthpiece for sucking up flower nectar that most Lepidoptera now use to feed. The proboscis is a famous tool of this insect group, with some like the Morgan sphinx moth, or Darwin's moth, using its foot-long tongue to wiggle deep inside orchids. Just about every butterfly and moth that has hollow scales today has a proboscis, Mr. van Eldijk said. That, he said, suggested there were butterflies and moths with proboscises fluttering around 200 million years ago. Previous studies had suggested that moths and butterflies with proboscises, which belong to the Glossota group, appeared only about 130 million years ago, when flowers first bloomed on land. The finding pushes back the date of this group of insects by about 70 million years, and refutes the idea that the proboscis first evolved alongside flowers. That creates this problem, said Mr. van Eldijk. If they had a proboscis, what were they using it for? The team suggested the insects used their tongues to suck up sugary droplets produced by non-flowering plants that made seeds, a group that includes today's pine trees. I totally agree with them, said Conrad Labandera, a paleoentomologist at the Smithsonian Institution of Natural History who was not involved in the study. He added that the finding may provide evidence that the iconic way moths and butterflies pollinate wildflowers today, flying from petal to petal, evolved millions of years ago with a completely different type of plant.